Hi everyone, welcome to my YouTube channel. In this video we are going to explore what is the window functions, and it's a really cool and super useful topic in the SQL. Don't let the name scare you because they are pretty straightforward once you get the hang of them. So let's start by thinking about something you probably already know about the aggregate functions. And for the practice, let's use the employee data table. For this, let's firstly start by grabbing all the information from the table, and it's employee data, and run the query. We see we have 4 columns like employee name and the department and salary per each employee, and hire date, the date when the employee was hired by the company. And if we are talking about the aggregate functions, we can say what do they do. They take a bunch of the rows and crunch them down into one single number. For instance, for these employees, we want to know the total of all their salaries. And for this, we can change the query like this. Select, we are going write it here, sum, and we want to use the salary column, which is this salary column, and from the employee data, and run the query. And you see, we get just one number, the grand total for the salaries of the employees. That's great for quick summary, but what if we wanted to see something different? What if we want to see every single employee on the list and also want to see the company's total salary listed right next to their name? And irregular sum function here, which is the here, will not let us do that because it collapses all the rows. This is exactly where window functions come in. Actually, they let us do the same kind of calculation, but they don't get rid of the original rows. And if we want to change this query into window function, we can use only one secret word, which is the over. This keyword turns a regular aggregate function into a window function. Let's change the query like this. For this, I'm gonna grab all other columns of the table. Let's write employee name, and let's grab the salary as well, and comma, and here I'm gonna write some salary. Here I'm gonna put over, let's as total salary, use alias here, and from the employee table. And if we run the query, now let's check what happened. We still get a list of every employee in our company, just like we started with. As you see, next to each person's salary, we have a new column, and it shows the total salary for the entire company. It's a very useful information because we see the individual data, name of the employee and salary, and also the total salary for the company. And it's a big picture that we used by the window functions. If we go back, we can say that without this over, the query was just using the aggregate function, which was the sum. And by using the aggregate function, we get only one single summary row. But with the over, we keep all the original rows plus a new column with the aggregate data. And this is how aggregate functions work, and this is the main functionality of the window functions. So here over is what makes the magic happen, because it tells SQL to look at this whole group of data and calculate something and don't collapse them. This is how window functions work. Now that we get the basic idea, let's look at the full recipe for a window function. And for this, let's use a simple employee table as well. And let's say we want to see the company's average salary next to each employee's salary in order to compare their salaries. For this, we can change our query like this. Let's select the employee name and the salary columns as well. And here, instead of sum, I'm going to use the average aggregate function, and let's change it as well, write average, and from the employee data, and run the query. You see, this is the average salary for the whole company. This is exactly what we just talked about. It calculates the average for everyone and put that same number on every row and keeps the original data as well. We see we have the employees here as well, and then we have another new column with the average salary for the all employees. And let's say that we want to see the department of the employees as well. And for this, I'm gonna put it in the select statement and run the query. Department. And you see now we have the employee name, salary, department, and average salary. Let's say that we want to see the average salary per department. You see we have different departments like sales, HR, IT, and marketing. We have total 4 departments, and we want to see the average salary per each department in order to compare the salaries within the department. And for this, we are going to use the partition by. The partition by is like the group by, but it does not get rid of any rows. It just tells the window function to restart the calculation for each new group. For example, let's use the partition here. Inside the parentheses here, I'm gonna use the partition by department. As you see, this is the department column, and I want to divide the data by the department. Now let's run the query, and we see we have different average salary per each department. For example, for HR, we see the average salary is 6,100. For IT, it's different. For marketing, it's different. And for the sales department, it is the different. And it means that now employees in the sales department will see the average salary for the sales team, and the employees in marketing will see the average for the marketing team. And we see the calculation is done separately for each department, and everyone gets to see the department's average right on their row. For example, Lily sees the average salary for marketing as she's from marketing. Then Ethan sees the average salary for department IT as he is from the IT department. And this is how we use the partition by in window functions. So this is the main functionality of the partition by. Sometimes you want to see how a value changes over time, and a classic example is a running total. Let's say you want to see how the company's total salary cost grew as each new person was hired. And we can use the order by with the window functions as well. Let's combine both of them, or partition by and order by together. Let's say we want to see a running total of salaries, but we want a separate running total for each department. And for this, let's change the query like this. Let's grab all the data, employee name, salary, department, and let's get the hire date as well. And for this, I'm going to change the function as the sum, as I'm going to calculate the running total, and over partition by department. And here I can write the order by. I can order by hire date as, let's just write sum. Let's call this column as sum department, and from employee data, and also order by, I'm gonna use it here, department and hire date, and run the query. Run the query. Let's see what SQL does in this query. It first splits data by the department. As you see, we have the HR data first, then IT, then marketing, and sales. Because it splits the data, because we have the partition by department here. Because of this partition by department, the query first splitted the data by the department, and then within each department, for example within that HR department, the query sorts by hire date of the employees and calculates the running total. For example, first Chris was hired, it was 2020, and the sum of the department or the running total per HR was 5,800. It is the salary for Chris. And then we hired David, and that's why the running total increased by 6,000. And then we hired Natalie, and that's why the running salary per HR department increased by the salary of Natalie, and it goes like this. And then we have Olivia in our HR department, and this is the sum of the all employees salary per HR department. As you see, this is the last employee in the HR department, that's why this is the running total for HR department. And then we have the IT department, which is the Frank was hired first in 2019, and his salary was 7,000. As you see, this is the total salary, and Frank's salary was 7,000, and then we hired Sophia with 6,700, and that's why the running sum of the salary increased by that number. And it goes like this. And we can see the same logic in the sales department and in the marketing department as well. So if we recap all the things together, we can see that the query started by splitting data into department with the partition by department, and then it ordered the data by the hire date inside each department. And then we use the sum window function here in order to calculate the running total of the salary per each department. And we see we have the order by department and hire date here. It means that after calculating everything, SQL sorts the final output within that order. And this makes sure that we see the employees listed by the department in the order they were hired. So this is how window functions work. Aggregate functions squish rows into one single cell, but window functions add a calculated value to each row without collapsing them, or the window functions keeps the original data and add new data column as well. And over here is what turns a regular aggregate into a window function, and partition by lets us create groups per calculation, and we use the order by in order to order data. So window functions are incredibly useful functions, and we are going to cover other window functions in our next videos. That's all for now.